Okay, so what is it all about? So Axxana product together with Oracle Data Guard provides zero data loss recovery to a remote site. People may ask, what's the big deal? You do Oracle max availability, Data Guard, you get recovery of zero data loss. However, the difference is that we do it regardless of the distance between the sites. It can be thousands of kilometers. We do it regardless of the nature of the disasters. Earthquake is type of a disaster that may destroy 2 data centers that are doing max availability between them. We do it in a very cost-effective manner. Typically, all synchronous solution cost a lot. You need a nearby data center, expensive communication lines, etc. And we do it with better performance than Data Guard max availability, and I'll talk about it too. So why? As Larry Carpenter said in one of his presentations, everybody basically wants zero data loss. That's the dream. But everybody also wants geographical separation, exactly because of the fact, especially people that live here understand it. They want a separation between the 2 sites because the 2 sites may be destroyed. And those 2 requirements don't go together. The zero data loss requirement and maximum separation don't work together because doing synchronous replication over a distance creates a lot of additional latency and performance loss. Now, why really zero data loss is important? I just want to talk about it a little bit because people don't remember anymore because they can't do really zero data loss and they agree to forget about it, so it's worthwhile remembering why it's worthwhile doing. So there is a problem of data reconciliation. So if you think about your data, at the end of the day, your data represents a real world. Whether it be bank money in your bank, whether it be inventory information or CRM information that keeps track of requests and what have you. It represents a real world. If you lose some of the data, believe me, after disaster, at some level, somebody will have to match the 2 and make them united again. That the real world, that the data in your databases represents the real world. And there are techniques to do it. Most of them are expensive and very tedious. And I will not go into the details, but I can talk about it a lot. There is a close application consistency issues, specifically with Data Guard. With Data Guard, each session of each database is a separate session. There is no consistency and no relationship between separate Data Guard sessions. If you have a couple of applications that are talking to each other and you have a disaster, they will not be in a consistent state at the remote site. So you'll be able to bring each application up, but when they will try to talk to each other, they will find discrepancies that did not exist in the primary site because you cannot make sure that you lost your data exactly at the same point for all applications if you're doing asynchronous. And that's a big problem that also needs manual intervention when you are doing recovery eventually. Decision to fail over is tough. People don't remember that. But if you are doing asynchronous replication, specifically in those cases where you can fail back eventually because it's not a total disaster. You lost some equipment, you lost something, you have an outage you want to fail over. If it's asynchronous, you will think 3 times before failing over because the failback is a nightmare, plus the fact that you'll be losing data, which is not true for synchronous replication. In synchronous replication, it's relatively easy to fail over and fail back. It's a simple decision. And last and not least, because of the last 3 bullets, the RTO, the recovery time, the total recovery time to bring really the application up and make them running is very long as opposed to synchronous replication. It's But on the other hand side, so if you do a synchronous replication, so synchronous replication is vulnerable to rolling disaster. In a synchronous replication, in a disaster event, if you lose your communication line between the site first, and some transaction will continue at your primary site without being replicated because you lost the line first, then you'll be losing transactions anyway. And the big problem is that it's very difficult to know that you lost transactions. If you think about it, in a synchronous event, you really, after that, you do need to check whether you didn't lose anything, because there is always a potential that you may have lost your communication line first. It's vulnerable to regional disasters, we talked about it. It's costly, and it's performance sensitive. In short, very few people really implement data guard in max availability. There are some, but people prefer to do it in max performance because it's simpler. So now Oracle in Oracle 12c came with something which is called Oracle Parsing, which solves some of the issues. The idea is, although I'll change tools. The idea is to have your primary site, to have your standby site at a very far distance, and in between to put sort of a relay, which is called a parsing site, which is at a synchronous distance from the primary site. And that relay does a asynchronous data guard replication to the remote site. So when the primary site and it fails and that thing survives, it continues to replicate to the remote site all the data, and you can recover at the remote site. Parsing really doesn't have a complete database instance. You don't pay additional license for this if you have active data guard. It's very lightweight. It's a single server, can support number of sessions, and it's just a relay between the primary and the remote site. And it really solves partly the distance issue. But there are still a lot of other vulnerability. It's still vulnerable to rolling disaster because between the two first sites, you still have synchronous replication, and there is a communication line, and the communication line can fail. It's still vulnerable to regional disaster, because if the parsing instance fails too, then you are left at the remote site with some transactions missing. And the cost of parsing site is also not negligible. You need to have a separate site for this. You don't want to put it in the primary site, because then definitely you don't win anything, and it's pretty costly. So Axxana improved this solution tremendously. In what way? It introduced, wrong tool. It introduced a device which is a storage and a server, very resilient. We took the idea of a black box of an airplane. If you think about a black box of an airplane, the black box of an airplane is designed to survive data after an airplane crash. So we took the same idea. We've built a unit which is a storage and a server with flash storage for mechanical reasons, vibrations and shocks, and a server inside a very, I'll show you later, in a very reinforced enclosure. It can survive fire, it can survive heat, it can survive vibration, it can survive shock. We dropped it from 5 meters and it continued working. It can survive penetration, all sorts of penetration attempts, physical penetration, dropping a rod that weighs 250 kilo from 3 meters. At the end of the day, it's very, very reinforced unit that is designed to survive most of the disasters. And I'm saying most because we didn't test for atomic explosion. In addition to that, inside it has its own battery that can transmit data for 6 hours, and we have a separate transmission means to transmit data after disaster based on cellular transmission 4G. So after a disaster, it will work autonomously and transmit all data that it captured inside to the remote site. There are other means to extract data. We have a long-distance Wi-Fi where we can extract the data to a laptop in case of a cellular failure. In a nutshell, it's really a bunker in a box, which is half rack size. So now, if you see this, what we did a replacement of the far sink. What we are doing here, it's not working suddenly. What we are doing here, we are putting the far sink instance into our box. We are putting that box very near at the primary site. We don't need a separate site. It can be very close to here because it is supposed to survive a failure at the primary site. And in normal operation, we really operate like a regular far sink instance that replicates to the remote site. When a disaster occurs, we basically switch to a cellular line and complete the data transmission over cellular line to the remote site to bring it up to date. That's the basic idea. Notice that this distance now is very short distance, so there is no latency, or practically no latency, that you have with a regular far sink when you are trying to put it 10 or 15 kilometers apart. And that saves you a lot of performance. We'll talk a little bit about performance later. So now you are getting a solution which is resilient to rolling disaster. It's resilient to regional disasters because it's designed to survive a disaster, and it's cost effective. No need for third site. I will not talk about this. So in many senses, it's better than max availability. Why is it better than max availability solution? Because it has it has much better performance, and we noticed for applications that are heavily updating, in heavily updating situations where the typical latency between the site is 0.3 milliseconds. If you go with this solution, you get about 30% better performance because you don't get that 0.3 millisecond latency, you get much lower latency, and you get about 30% better performance because of lower latency. You can offload compression, and if you are going long distances, you want to compress. Max availability solution replication, very difficult to compress data. You don't have enough time. Compression takes CPU and time. Now, from our box, you do the compression to the remote site, and you can save the bandwidth, and you can offload support of local standbys. So typically, banks have local standbys, banks and other organizations, on the data center for other purposes. Now, all that standby is being replicated from the far sink instance, not from the database server itself, but by this you save additional performance on your primary server. And for high availability, the failover is very fast because in high availability, you have your wireline communication. You don't need to switch to cellular. And if you don't switch to cellular, you can fail over very fast. You can transmit that leg in seconds, and you'll get it at the remote site and can recover. So that's about 12C. Are there any questions? So in 11G, unfortunately, there is no far sink solution. So we do something else. What we do there, we basically multiplex a copy of redo logs to our box, but I let Serdar talk about it because he implemented the solution in his bank. Thank you.
So,